Hey guys, this is Carrie, and I want to make sure that we get some good practice with this review before we have our quiz on our next class. So let's take a look at these problems. So for reviewing the graphs, first off here we've got the pop and lock, so this has got to be a cube root shape. So we go f of x is equal to cube root. Most cube roots are going to start with 0, 0 as the vertex point, but this one is shifted over 6 units and up 2. So we need an inside transformation of minus 6, the opposite, because inside is always the opposite, and an outside transformation in the y direction of plus 2. All right, for problem 2 here, this is just the regular wave, so this one is going to be a square root problem. And I shouldn't draw my square root like that because we're going to need to have an inside and an outside transformation. So in this case, our inside transformation has to move us left 3, opposite of minus 3, opposite for inside is going to be plus 3, and then outside is as expected, so plus 4. Nice. Notice that the cube root gives it the pop and lock shape, and the square root gives it the wave shape. Let g of x equal that. What's the domain? Oh man. Well, there's nothing in this problem that tells me to graph it. But whenever we're asked a domain and range question, it's often helpful for me to think about a picture of the graph. So in this case, our graph is a square root graph, so it's a wave, that's been shifted. Let me see if I can actually do this. That's been shifted, and I'm drawing a scrap graph here to help me out, shifted 4 to the left for the inside, and down 7. So I'll just mark those on the graph. 2, 3, 4, back 4, and down 1, 2, 3, 4, 5, 6, 7. That's our shift. Domain is all included x values. So I like to use the highlighter for this. I haven't done this year, I don't think, though. So if we think about all included x values, we get all of these x values. Because the lowest x value that we hit is negative 4. We don't go anywhere beyond that. And then this arrow means we keep actually going forever. So what we have is we've got, for our domain, negative 4 to infinity, starting at negative 4 included, because it's a solid bubble, all the way up to infinity. Now, for this, we have it in inequality notation. We haven't done that in a while. Well, if we're going from negative 4 to infinity, that just means that x is bigger than or equal to negative 4. Because that's the same description. All right, so write the equation of a square root graph that has domain x is bigger than 3. So we know the lowest x value on our graph is 3. The lowest y value on our graph for the range, y has to be bigger than negative 4. The lowest y value is going to be here. And if this is the lowest x value and this is the lowest y value, we know that our graph will have a square root shape. So what we can do is we can imagine moving this square root shape around. Well, if it's here, my y value is too low because I'm below the y line, negative 4. From here, my x value is good, but it has to be hitting 3. So actually, I think what we need is this one here. Because here, the lowest x value is 3. The lowest y value is 4. All of our y values are above this line, which is good. So this is the line y equal, or the curve y equals the square root of x minus 3, opposite for the inside transformation, minus 4. Tough one. That was a challenge for a reason. Solving with square roots. All right, x squared equals 49. Square root both sides. Square root cancels square. We get 2 answers, though, because we were expecting 2 answers with the power of 2. So x is equal to 7 or x is equal to negative 7. And checking both of those answers, if you square 7, 7 times 7, yeah, that's 49. And if we square negative 7 times itself, yeah, negative times negative, that also gives us 49. So here we go. All right, now this one always used to confuse me as a student. Oh man, I hope I just didn't change my settings. I don't know which pen. Oh, that's not the right one. Maybe this one? All right, whatever. Square root of 49 is not going to be two answers. This is just one answer. It's just the positive version. It's just 7. All right. I wish I remembered which one it was on, because I liked the style that I was writing in before. Which of the following choices represents the solution set to this thing? Okay, this one looks tough here. But we know that we're not going to be able to solve for x if all this stuff is trapped inside of the square root. So to get rid of that square root, we're going to go in and we're going to square both sides. Now, although this is the correct step, I should be a lot more careful in how I write this. I need to make sure that negative 3x is all in parentheses. This gives us x squared plus 72, because the square and the square root canceled. And here, negative 3 squared is negative 3 times negative 3, 9. X squared is x squared. And now we have no more square root. So all we've got to do is isolate x. Let's move all the x squareds to one side of the equation. We get 72 is equal to 9 minus 1, 8x squared. We divide by 8 on both sides. We get x squared is equal to 9. All right, here's the key, right? Square means that we're getting 2 answers here. So we take the square root of both sides, and we get x equals 3, or x equals negative 3. Now it's very tempting to circle the answer and move to the next problem, but we're not going to do that. Because square roots are dangerous, right? They can give us extraneous solutions. So even if we don't want to be careful, we need to be, because the correct problem-solving process here can actually give us incorrect answers. So you check each of our solutions separately by plugging into the original equation. So you have square root 3 squared plus 72 equals negative 3 times 3. 3 squared is 9. 9 plus 72 is 81. Negative 3 times 3 is negative 9. The square root of 81. Well, the square root of 81 is actually just one number. That's the square root of a number. It has to, when you put that in our calculator, it just gives you 9. So 9 and negative 9 are not the same. So this solution is an extraneous solution. We need to cross it out. We need to check negative 3 as well. So checking this one, because it can be that both are actually extraneous. So here we go, plugging in negative 3 for both x values here. Notice that we're using parentheses. If we're using our calculator, we've got to be really good about that, or our calculator won't actually square the whole thing. So this gives a square root of 9 plus 72 equals negative 3 times negative 3, 9. Square root of 81 is equal to 9. 9 equals 9. No, oh wait, no, that is correct. I almost crossed it out. X equals negative 3 is the correct solution. So it must be just this one. Oh no, x equals negative 3. All right, wow. I almost double tricked myself despite doing the check. I got carried away with things. All right, if f of x is equal to this, oh, this is a cool one. I really enjoy these inverse problems. Then determine f inverse of x. Okay. Well, we have an overwhelming looking problem here, but a big lesson that we've been talking about is in math, oftentimes we can avoid becoming overwhelmed because we know we have a solution process, an algorithm, a procedure that will always allow us to find an inverse. So first things first, we change f of x into y. And once we take that first step, we can really relax because things become a lot more evident. Y and x need to switch because inverses are opposites. So switching them gives us this. Okay, we're already like cruising through this problem. Now the last couple of steps that we need to remember here are a little bit trickier. We just need to solve for y. And I think this is probably the hardest steps, but these are just inverse operations. So times c on both sides. It looks tricky because it's all letters, but really it makes it better because we don't actually have to use the calculator at all. All right, so there we are. A couple steps away from solving for y. Minus b on both sides. So you get cx minus b. They can't be combined because they're not like terms. Square root of y minus a. Solving for y next, we need to get rid of the square root. So we square both sides. No, I'm actually not going to square this. I'll leave it all in the parentheses with that exponent up there. And now we're one step away from solving for y here. So we add a on both sides. And that gives us y equals cx minus b all squared. And then we added to that a here, because y by itself. Finally, we want to write f inverse of x is equal to that, because we made up the variable y. And that's our final answer for this one. There were other final answers for it as well. For instance, you may have got, let's see if I can do this in my head, c squared x squared minus 2bcx plus b squared plus, oh, it's not 9, it's a. Why can't I read my own handwriting? Sorry about that. That's another possible answer, but I think this is a trickier answer to get, so we can avoid looking at that one until the next unit, maybe. All right, fractional powers. Explain why 64 to the 2/3 equals 16. I don't think because I put it in my calculator is going to be, or because my calculator says so, I don't think that's the answer that we're looking for here. Really what we want to use is we want to use our understanding of fractional exponents to explain this. So cube root of 64, and then we have to square it. Now 64 squared is going to be a huge number. I do not want to break that number down with my cube root. So luckily what we remember is with these fractional exponents we can do them in either order. So we could do the cube root first and then square it. The power can go either inside or outside. Cube root of 64 is not too bad though. This is one you may know automatically. And if you don't know it automatically, we just need to break 64 down. 64 is 8 times 8, 2 times 4, 2 times 4, 2 times 2, 2 times 2. So we're going to jailbreak these numbers. So we get cube root of 2 times 2 times 2 times 2 times 2 times 2. And that's kind of nice because we're making groups of 3 with an index of 3. These cancel out. 2 escapes, 2 escapes. 2 times 2 is 4. Now we could draw our cube root jail, but there's nobody left in it. Everyone died or everyone escaped. So we don't need to draw the cube root jail because there's nobody in it. Now the last thing to remember is we did have this squared outside, which means we still have to square our 4. 4 squared, 16. So maybe you want to explain those steps in words. You could say, I rewrote it as a root and a power. I broke things down using the jailbreak method. Finally, I remembered to do the power, and that gave me 16. Write the expression below in simplest radical form. Oof. Cube root of a negative, well, hey, we can do that one because it's odd. The final answer is just going to be negative, whatever we get from doing this. Next up, got to break 24 down. 3 and 8, 2 and 4, 2 and 2. So you get negative cube root of 2 times 2 times 2 times 3 times x to the 15th and y to the 32nd. Now the number part is always the hardest, I feel like, because we actually have to break that down with a factor tree to find the prime factors. These are prime numbers, they can't be broken down any further. And then now we need to actually find our groups of 3. Cube root jail says groups of 3, 2 die, 1 escapes, so you get negative 2 cube root. For x to the 15th, I don't want to write out all those x's, but with a cube root jail, how many groups of 3 can we make with 15? I think this is 5 groups, 0 leftovers. So with 5 groups, whoa, I don't want to draw my cube root jail there yet. 5 groups, 0 leftovers. We'll have 5 escape, 1 from each group. The other 10, 2 from each group, die. We're left with y to the 32nd. Y to the 32nd, okay, we can make, try and make groups of 3 there. We can make 10 full groups. 10 times 3 is 30, so we'll have 2 leftovers. So you get y to the 10th. Cube root 3. No x's from the 0 leftovers, but 2 y's. When fully simplified, what is the value of that? Anything to the 1/4 is just 4th root, that thing to the first power. But what we can remember here is, well, anything to the first power just means we have this whole group one time. So I'll erase the parentheses and I'll erase the 1. 4th root means we're going to be trying to jailbreak in groups of 4. 16 is 4 times 4, 2 times 2, 2 times 2. So we get 4 2s, which is nice because we're trying to escape in groups of 4. They try to escape, 1 gets out, the rest die. E to the 403rd, man, big numbers. This becomes 4th root of, whoa. People escaped. So 2, from a to the 403rd, groups of 4, that's 100 full groups to me. B to the 47th, well, 44 is super close to 47, so I think we can fit 11 full groups here. Now, you may not have seen that as automatically as I saw it with the 47, or maybe you did, I don't know. But what you could do here is you can go over to Desmos. You're taking 47 Bs, splitting them into groups of 4. Looks like 11 full groups to me. 11 full groups times 4, that accounts for 44 of them. So you've got 3 left over. B to the 11th, 4th root, a to the 3rd, b to the 3rd. If f of x is equal to this, find f of 64. Okay, this problem is actually probably, to me, the easiest challenge because all we have to remember here is 64 is the input when it's in parentheses. So if we apply f to 64, that gives us 64 to the 3/2 plus 64 to the 2/3. F of 64 is equal to, oh man, okay, well here's where things get a little interesting from this unit. Second root of 64, and we could put the 3 inside, but 64 cubed is going to be a huge number. So we'll cube it afterwards. So we'll make it tiny first like this, and then cube it. And then we have here the cubed root, because 3 is on the bottom this time, of 64, and then we'll square it afterwards because squaring will make it really big with a number. Now there's something here that's a little bit unnecessary. The second root of a number right here, that's just the regular square root. So we're not going to write the second root there because that's implied by having the square root. Square root of 64 is a nice number. That's just 4 cubed. Cubed root of 64, we did a little earlier. Cube root of 64, I remember that was 4, so I'm just going to write it. Sorry, square root of 64, I got that wrong. Square root of 64 is not that. Square root of 64, 4 times 4 is just 16. Square root of 64 is 8. So we get 8 cubed here. Sorry about that. Cubed root of 64 is 4. My bad. And then we still have the squared here, so we write that squared. 8 cubed is 512. 4 squared is 16. And we get our final answer here. F of 64 is equal to an output value of 518. All right, guys, that's it. If you understood everything here and you feel confident that you're able to execute all of these skills, you're going to do great on your exam or quiz next class. All right, bye, guys.